ladies and gentlemen, esteemed guests, and fellow enthusiasts of engineering marvels. Today, I am honored to delve into the intricate and fascinating world of clock engineering. Clocks have been an integral part of human civilization for centuries, serving not only as timekeepers but as symbols of human ingenuity and precision. Engineering behind clocks is a testament to our relentless pursuit of measuring and mastering time, and it has evolved over millennia into an art and science of unparalleled complexity. Generally, clocks, whether they are traditional mechanical pendulum clocks or modern digital timepieces, are fundamentally governed by the laws of physics. In the case of traditional pendulum clocks, the physics of oscillations takes center stage. The pendulum, a suspended weight, swings back and forth under the influence of gravity. This movement adheres to the principles of simple harmonic motion, characterized by a constant period of oscillation, which means that the time it takes for the pendulum to complete one full swing is determined solely by the length of the pendulum and the strength of gravity in that location. Another crucial element of clock physics is the escapement mechanism. This mechanism regulates the release of energy from a wound spring or a falling weight into the clock's gears. It operates on the principle of periodic impulses, allowing the clock's gear train to advance at a constant rate. The escapement ensures that the clock's hands move in discrete, regular increments, thereby marking the passage of time with precision. In spring-driven clocks, such as many vintage timepieces, potential energy plays a pivotal role. These clocks rely on a tightly coiled spring as their primary energy source. As the spring unwinds, it releases its stored potential energy, which is then transferred through the gear train to drive the clock's hands. The rate at which the spring unwinds is meticulously controlled, ensuring the clock's accuracy over time. The clock's gear train and the mechanical advantage it provides are also vital aspects of clock physics. Clocks use a complex system of gears and wheels, each with a specific number of teeth, to divide time into precise intervals. The manipulation of gear ratios allows clockmakers to control the speed at which various components of the clock move, thus ensuring the accuracy of timekeeping. Moreover, energy transfer and friction are significant considerations in clock mechanisms. Efficient energy transfer is essential to ensure that energy from the mainspring or weight is transmitted effectively through the gear train. Minimizing friction, both in the bearings and between gear teeth, is critical for maintaining the clock's accuracy and longevity. Materials science plays a role in clock engineering as well. Clockmakers choose materials like brass and steel for their durability and resistance to temperature changes. Understanding the coefficient of thermal expansion of these materials helps minimize the impact of temperature variations on clock accuracy. In modern clocks, especially those used in digital displays, electromagnetism and semiconductor physics are paramount. Quartz crystals, for example, exhibit a precise and consistent vibrational frequency when subjected to an electric current, making them ideal as oscillators for quartz clocks. Digital clocks rely on electronic components and microprocessors that manipulate electric signals to display time accurately. Overall, clocks are intricate devices that encompass a broad range of physics principles, from the mechanics of oscillations and gear systems to the transfer of energy and materials science considerations. They represent a fascinating fusion of classical and modern physics, underscoring their role not only as practical timekeeping instruments but also as remarkable manifestations of human scientific and engineering ingenuity. But, let us embark on this journey through time, exploring the engineering marvels that have shaped our understanding of the passing hours and minutes. Clocks have a rich history dating back to ancient civilizations. Early timekeeping devices, such as sundials and water clocks, laid the foundation for more complex mechanisms. The concept of dividing time into hours, minutes, and seconds was revolutionary, requiring intricate engineering. The story of clocks begins with the earliest human civilizations, where the need to measure time was of paramount importance.